Alright guys, quite an interesting numerical. In a conical pendulum, a string of length 120 cm is fixed at rigid support and carries a mass of 150 gram at its free end. If the mass is revolved in horizontal circle of radius 0.2 meter around a vertical axis, calculate tension in the string. G given is 9.8 meter per second square. Okay guys, let's now try and understand the situation. Obviously given is conical pendulum, so conical pendulum is around here. Now in case of conical pendulum, we know if this is the bob, tension is always towards wherever this string is attached, alright, upper direction shown at, and we also know that mg is facing downwards towards the gravity, alright, but we don't find anything balancing mg. So what do? So we resolve tension. Alright, we resolve tension into cos theta and sin theta, t cos theta, t sin theta, and we are aware now that as per resolution of vector, the component which is adjacent to theta gets cos, so this gets set. So this is t cos theta and this is t sin theta. T sin theta we are not interested right now because t sin theta is what is providing the centripetal force for its rotation, responsible for its rotation. Alright, so t resolved into t cos theta, and this t cos theta is balancing mg. Alright, so we have t cos theta is equal to mg. We intend to find tension, so we take cos theta in the denominator, so we get this formula: t is equal to mg upon cos theta. Fine. Now cos theta, what is cos theta? Now if we check out triangle, now this is a right angle triangle. What has been provided is, this is, though given length is 120 centimeter, we are not concerned with centimeter, we are not into CGS system, we are into SI or MKS or SI system. In a SI system, we have got to convert centimeter to meter. We know conversion factor is 100, so divided by 100, so we get 1.2 meter. So this length which is there, we know is 1.2 meters. Alright, what else? We also know that radius provided is 0.2, radius provided is 0.2 meter. So cos theta, can we take care of cos theta? Yes, cos theta is, so this is our theta. Cos theta is adjacent over hypotenuse, that is h over l. Alright, we know L. Alright, we know L. L is known, no problem. H is not known. We can jolly well find out via Pythagoras theorem. It's waiting for you to be applied. So Pythagoras theorem. So it is what? L square hypotenuse square is equal to sum of square of other two sides. Alright, so that is what is L square plus R square. Done. So what all do we know? Here L we know, which is 1.2 square. H square is the thing that we intend to find, plus R square. R is 0.2 square. Alright, so what is the answer for this? So what do we do? Next is, we want to take it in terms of h square, right? H square. So we take this here, so it becomes 1.2 the whole square minus 0.2 the whole square. On sorting out, what we get is 1.4. Alright, now see, easier way to do is, now this is 1.2. So what I do is, I convert it into 12 upon 10 square. Alright, and this also I minus 2 upon 10 square. Alright, so this becomes what? This becomes, we know, 144 upon 100 minus 4 upon 100. Alright, so done. So now common base, so it is 144 common base, right? So it is, okay, I'll put it like this, 144 minus 4 upon 100. So that is what? That is 140 upon 100. So that comes to 140 upon 100, and that becomes 1.4. So easy, yeah, right? So what I did is I just converted that decimal into, I removed the decimal, alright, by dividing it by 10, alright. So that way, so that's how you get 1.4. Now, so h is equal to a root of 1.4, which we can directly see from log and find its value. Alright, so we find it to be, so we find h to be 1.183 meters. Done. So we have got h also. So now what? Cos theta is what? Get into cos theta. So cos theta is equal to h, that is 1.183 divided by L. L is 1.2 meters. Alright. So this is also meter, this is also meter. So meter gets cancelled. So cos theta is equal to 1.183 divided by 1.2 meter. Meter gets cancelled. So the value that we get is this for cos theta. Alright. Okay. Now this has to be tried by log. Okay. So learn log by sorting out such numericals. You know what you should be doing is just take this figure and find out log and see whether you get the answer or not. Alright. Not then try it again. Alright. Okay. Fine. So cos theta. We got the value of cos theta. Now what's our next mission? The next mission is straight away finding tension. I'll do it here. Tension. Let's find out tension. Tension is mg over cos theta. Now m already given is 150 grams but not valid. So we divide it by 1000 to get it in terms of kg. 0.15. So 0.15 kg. And your gravitational is already provided. It is 9.8. So I just put the value. Alright, and cos theta we got it just now as 0.9858. Now see, if you expect your answer somewhere to be, now see this and this 9.89, if you divide this by this is what? This is 10 times approximately. So your answer would be somewhere around 1.5 or somewhere around that. Alright, now this value is slightly, so it would be less than this value is slightly greater than this value. So it would not be 10, it would be, the multiple would be slightly lesser than 10. Alright, so your answer that you expect is not 1.5 but slightly lesser than 1.5. Now these are the tricks that you've got to use while you're doing JEE. Now no need of calculation. Now you would be given options, right? Now here the answer comes to 1.491 Newton. Tension is in Newton, it's a force, right? So Newton. Alright, now let me try and make you understand JEE style, like, now see, this is 0.15. Now this and this, suppose if it would have been 0.98, if you divide this, if you cancel this, you get 10 over here. Alright, so it is 10 times this, so 10 into this becomes 1.5, but now the value would be slightly lesser than 1.5. Why? Because the denominator is slightly more than 9 so the value, the multiple would not be 10, would be slightly lesser than 10. So that's why the value that you would get is not 1.5 but would be slightly lesser than 1.5. Now these are some of the tricks which I'll keep on teaching for JEE, CET, and NEET and all those places, all those MCQs where you don't have to keep on solving, you just have to do approximations. Alright, so I hope you understood. If you didn't understand, please review the video and try to understand. Alright, so our final answer is 1.491 Newton. So what did we do in this? We used conical formula, we used the conical pendulum thing, and then we also did what? This was our formula, so cos theta was our problem. So cos theta, we knew this, we knew this, so we could find cos theta by our triangle method. Alright, by our triangle method we could find. So what basically, let's summarize, what did we do? First of all, as given, conical pendulum, fine, and in conical pendulum we had the length and the radius given. Alright, obviously we converted whatever required into SI system, alright, the units, alright, and then they asked us to calculate tension. So we knew tension formula was T is equal to mg over cos theta. We put in m given, g given, Cos theta not given. Cos theta we found out by triangle method. All right. So cos theta we know adjacent over hypotenuse. We use that and we've got cos theta. Then after getting cos theta, then I also showed you a simple methodology just to do this calculation. All right. So decimal, remove decimal. That becomes very easy because you know by heart 12 square. So we jotted down that, and then 10 square becomes 100. That we did 2, we know 4, 100, common base. So just 144 minus 4. So it becomes 140 over 100. So that comes to 1.4. That is one method which I showed you. Then h is equal to root of 1.4. That we have got to do by log. Directly log, you can get the value. So got that value. Then cos theta we went into. So in case of cos theta, it was what? The formula for cos theta. We wrote here the formula for cos theta. Cos theta, which was h over L. That's adjacent over hypotenuse, h over L. So we got h. So we just substituted h over there, which is 1.183, and L was given. Alright, so we got it from there. From here, we got the value of cos theta. Then cos theta once got substituted there. And then we did this calculation and we got the value to be 1.491 Newton. Alright, okay. So please review the numericals that you do, as I've always been saying. Once numerical done, yes, be happy that you got the solution. Alright, but then after that also recap what you did. Store it in your data bank. Alright, okay.